Alright, so this video is talking about the idea of thrust and pressure and how they relate to our water rockets, okay? So firstly, I'm going to do most of this in diagrams, alright? So firstly, let's quickly remember what our thrust and our pressure actually are, okay? So here's our water rocket, alright? So it's obviously heading in this direction. Here's our end with our hose connected. I'll draw our hose in yellow. Alright, so this is where the hose was going to our pump, and then we had it filled to a certain level with some water. Okay, so the thrust is a force. Alright, the thrust is a force, so it's a theoretical thing that is pushing it forward. Okay, now in order for the thrust to push it forward, it has to be pushing something backwards. So I'm going to write this as thrust, all right, and there has to be something that it pushes backward. Now in this case, the thing that it's pushing backwards is the water, okay? Now the way pressure relates to this is that the part that isn't water, that's just air, all right, it builds up so much air that the air starts pushing outwards in all directions, okay? Now in nearly all cases, it's just pushing against a bit of plastic, but here it's actually pushing against the water. Now, while the hose is still connected, that's obviously not an issue, but when the hose disconnects, all right, it's pushing the water out, which is pushing the water backwards, which is creating this thrust that is actually driving us forwards, okay? So the idea is we want to look at how the amount of pressure that's in this air relates to the amount of thrust going forwards, okay? Specifically, how it relates to how much water is actually in there. So I'm going to use 3 different examples here. So I'll just draw these ones a lot more basic, okay? So here's our bottle. Let's assume in all 3 bottles that they're actually getting pushed upwards, okay? And third bottle here. All right, now they're drawn terribly, but let's pretend that they're all the same size. All right, so our first bottle is one that we nearly completely filled with water. Okay, so all this is water. Okay, and then our second bottle is one that we filled with barely any water. And then our third one, we're going to fill with a medium amount of water. So there's a couple of different things that you have to be aware of when we do this. So firstly, you need to know, all right, that the amount of thrust, okay, the amount of thrust that gets generated is equal to the force pushing back the water, okay? So I'm going to call that the force pushing back the water. Now, the next thing that you need to note is that the force, both thrust and the force pushing back the water, is equal to the mass times the acceleration. Okay, the mass times the acceleration. So what this means is that more mass means more force. All right, more force means more acceleration. Okay, but the thing is that if the force is kept the same, all right, then mass and acceleration are inversely proportional, which means that if we keep the force the same and mass goes up, then acceleration has to go down. Okay, so the thing to be aware of is one like this, okay, where there's lots and lots of water, there's lots of mass. So when the water gets pushed out, there's lots of mass getting pushed out, which, as we said, is increasing the amount of force. All right, as we increase this force, we have to increase thrust as well because they're the same. So if we have lots of water in there, lots of mass means it's all getting pushed out. If we have very little water in here, then that means there's very little mass and hence, you know, very little force. Medium amount means we have a medium amount of mass, hence a medium amount of force. But the other thing that we noticed was that when we filled it up ridiculously a lot with water, we didn't get very far at all. And this is simply down to the amount of air that's in here. So if let's make our air, I'll make our air white, okay? So here is our air in this